Move on to something far less dire and something far more hopeful. It's a journey deep into the sea. After Chandrayaan, India is set to launch Samudrayaan with the deep sea diving vessel Matsya. What is the science beneath this and what is the mission all about?
Well, after successful space missions to both the moon and the sun, Indian scientists are gearing up for quite literally a deep dive to unlock the mysteries deep in the heart of the sea. That's right, India's next big endeavor is Project Samudrayaan, which involves sending a team of 3 humans 6 kilometers below the ocean surface in an indigenous submersible. Now, the submersible will be called Matsya 6000. It's going to be a self-propelled manned submersible. It's going to be carrying about 3 humans 6,000 meters underwater, and it's going to be equipped with a suite of scientific sensors and tools for deep sea exploration. Now, the submersible will have an endurance time of about 12 hours of operational period and an additional 96 hours in case of an emergency. Now, the primary objective behind Mission Samudrayaan is to explore valuable metals and minerals in the ocean, which include cobalt, nickel and manganese and many more. Now, in fact, the submersible has been in development for nearly 2 years and it's scheduled for its inaugural sea trials off the Chennai coast in the Bay of Bengal early next year. It's being developed by the National Institute of Ocean Technology, or NIOT, in Chennai, and the Union Minister of Earth Science, Kiran Rijiju, on Tuesday shared images of the under construction Matsya 6000 as well as some details of the Samudrayaan mission. He added that the mission will not disturb the ocean ecosystem and will support the blue economy vision of Prime Minister Modi. In fact, currently a team of scientists are looking into the design a little bit more cautiously after the horrific tragedy that befell the Titan submersible by OceanGate, which had taken tourists down to the Titanic wreckage in the North Atlantic Ocean in April earlier this year and had subsequently imploded, killing all on board. Now, Matsya 6000 is a remotely operated vehicle, and its passengers will be communicating with the researchers above ground through acoustic waves at 600 meters as the pressure down in the ocean will be more than 600 times more than the pressure at sea level.
All right, Nayantara, thanks very much for sharing those details with us. My colleague Pallav Bagla, an expert in science, every aspect of that, joins us now. You've actually sat inside the Matsya, right?
Absolutely right, Vishnu. I've had the opportunity of seeing it very closely. I sat inside the Matsya and I saw the program as it is developing and as it is shaping up. It is still some distance away from doing the 6-kilometer dive. We still need the titanium sphere. That is still some distance away. The steel sphere is there, and they've had a run without humans, which goes down to some level of the sea. But now they want to do a run with Matsya 6000, a little deeper into the ocean, and that would be the first trial run. But this is a very interesting project because we have at one end India's Gaganyaan program, which is to send an Indian astronaut into space from Indian soil. And then you have on the other end the Samudrayaan program, which is to send an Indian, actually 3 Indians, deep below the sea to map and look at the ocean's floor. And you'd be surprised to know we know more about the moon surface through India's Chandrayaan than we know about the Bay of Bengal and the Arabian Sea. So Samudrayaan would be charting new territory and also looking for minerals. And I can show you, Vishnu.
Yeah,
I'm currently at the Institute for Minerals and Materials Technology, part of the CSIR in Bhubaneswar. And what I hold in my hand is a polymetallic nodule which has been extracted from deep below the ocean by Indians. And this is very rich in manganese, cobalt, copper, and nickel, all elements which are required to power India's economy, especially for electric vehicles. That is why there is tremendous interest to mine these polymetallic nodules, the one which I'm holding in my hand.
And, just in terms of the submersible, is it itself, it's self-propelled? Does it move around like a rover, or is it tethered to a ship on the surface and essentially goes up and down?
No, the Matsya 6000 is not tethered. It can propel itself on the ocean bottom. And it can go in all directions, but it has a small endurance. It is not very large. It's about 12 to 16 hours of endurance under the sea, which is what is being planned. But still some distance away, because these are complex technologies. And again, you would be surprised to know there is deep involvement of the Indian Space Research Organization in Samudrayan. The sphere of Matsya 6000 is actually going to be made by titanium, and the best technology for titanium exists with the Indian Space Research Organization. And that is how there is a interlocking of the Indian Space Research Organization with Gaganyaan at one end and Samudrayan at the other end. But there was much talk that there would be a discussion between a person which is 6,000 meters below the sea and with an astronaut in space. That seems very unlikely.
Right.
That was far-fetched. But definitely, Samudrayan is a very ambitious program. And India is the only country which has an ocean named after it, the Indian Ocean. So we have a lot of exclusive economic zone, which is India's own. We have a 7,500 kilometer shoreline, and all of that is full of many resources, both bioresources, mineral resources, and all of them can help in India becoming the trillion-dollar economy which India hopes to be as it becomes a developed country.
So is that what we are looking for? You've got these pictures on the screen. We're looking for rare minerals, right?
Absolutely.
And
These
so
polymetallic...
Pallav, the question therefore is, how do you detect rare minerals under the ocean? You can't prospect the ocean with a tiny Matsya 6000, obviously.
No, see, India has already surveyed the deep ocean. There was a whole program which has been going on for the last 2 decades, and we know exactly how much area. We have 75,000 square kilometers of ocean area which India can exclusively mine at the ocean bottom, and that is all been mapped, and we know exactly where there is concentration of these polymetallic nodules. So one of the efforts would be to harvest these polymetallic nodules, these small kind of black potatoes which exist as concentrated metals on the sea floor. And when you bring them up, and this is one of them which has been brought up from the Indian Ocean and I hold in my hand, this particular, it can give you a lot of critical metals, critical minerals. So there is both the blue economy at one end, where you're looking at ocean resources, and also looking at minerals.
Sure.
See, 70% of the earth is ocean. So all of us are living literally on 30% of the land, which is holding the carrying capacity is being held by that 30%.
Yeah.
So if one is able to go in and tap the ocean for more, it would be a wonderful opportunity. But it has to be done carefully. It has to be done with environmental sensitiveness, which is what Minister Rijiju has said.
Pallav, great speaking to you. Thanks very much. It's fascinating technology. It really is. And let's see how far we can get ahead with this, because it is time for India to be mounting these deep sea missions. It is absolutely essential for